In this video, we're solving quadratic equations. Okay, so let's start with this zero product principle. What does that mean? Before we jump into an example, if a times b equals 0, think about that for a second. You have some product, which means multiply, right? A times b. Then what has to be true? Well, in order to multiply two numbers together and get 0, one of them has to be 0. That's all we're saying here. So if a times b equals 0, then either a is 0 or b is 0. Okay? How are we going to use that principle to solve equations? Well, let's take a look at my first example. I have a product here, right? We have to recognize that. That's that guy times that guy. X minus 8 times 2x minus 3. So the idea is if either one is 0, you have a solution. Right? You can think of this as the a and the b if you want. If a times b equals 0, then one of those has to be 0. So x minus 8 could be 0, or 2x minus 3 could be 0. Okay, so that's the concept. Now we're going to have to solve these equations. But the idea is the work you have to do is to set each to 0. The concept is that either part of the product could be 0 based on this principle. The work that you have to do is take each part of the product and set it to 0, like we did right here and right here. Okay, and then we remember our old algebra skills of solving linear equations. These are two linear equations. So there's one answer. And then we divide by 2, and then I get my other answer as x equals 3 halves. Okay, so it's 8 or 3 halves. You don't really need the word or in there. Sometimes you'll see it listed kind of as a set, 3 halves, kind of 8. Either way, you can indicate your answer. I'll just circle each of them. Okay. All right. So think about, why are we doing this now? Well, you've been doing some factoring most likely. Doesn't that look like something that's been factored? Okay. We're going to get there in a minute, but first we're just practicing with the zero product principle. Number 2, here I have a product. That's the key. Recognizing it as a product, and the fact that it's equal to 0 is of course also important. All right. So set each part of the product to 0. Each part that has an x term in it, like this one, set it to 0. Negative 3x equals 0. All right, that happens to be a monomial, but it still has an x term in it, so that means it can be equal to 0. There is a value for x that causes that to be 0. We're going to find that in a second. Same thing with this one. So again, the concept is each part of the product could be equal to 0. The math work is set each part to 0 and then solve. This one I'd have to subtract 2 from both sides. That gives me one answer. And if negative 3 times x equals 0, what's x have to be? Well, it has to be 0, right? Because negative 3 times 0 is 0. Or just do the algebra. Same algebra as always. Divide both sides by the coefficient of x. X equals 0 divided by 3. 0 divided by 3 is, of course, 0. Okay, so you notice we have two answers for both problems 1 and 2. Take a look at number 3. Okay, solve that equation. Well, I'm going to solve this by factoring. I don't have a product there. But when I factor, I create a product, right? So always look for the GCF first when I factor, right? I'm always looking for the GCF first. Sometimes a problem will have it, sometimes it won't. Okay, so another thing, if I'm using the zero product principle, I have to have my equation set to 0. Okay, so first set to 0, then look for GCF, and then think about all your other factoring methods. Okay, all the other ones you've learned. All right, and then the fourth step will be to set each factor to 0. Okay, this gives us kind of a step-by-step process to work with. So we're going to see a bunch of examples. So this one, follow that process. It's already set to 0, so that's good. Look for a GCF. This one does have one. It's x. And now I'm setting each part of the product to 0. One case I don't have to do anything. The other one I just have to add 17 to both sides, and I am done. So that's a case that wasn't, note the first two. Let me scroll back up here. The first two examples were already factored, essentially, right? They were kind of in factored form, so we just set to 0. Same thing with number 2. Number 3, I had to first set it, well, it was set to 0, but what I had to do differently in number 3 than from 1 and 2 was I had to factor it myself. That wasn't factored. And that's mostly what we're going to be doing. Let's see if that happens in problem number 4. Looks like it. Right, it's already set to 0, so that's good, but I got a factor. So first look for GCF. There is no GCF, but this is a trinomial, and I know how these guys factor. That leading coefficient there is 1. It's a trinomial, x squared x number term. I know to get the x squared, if I were to FOIL, it'd be x times x. So I just need two numbers that multiply together to give me 6, and add together to give me that -1 there. So that should be 3 and 2, right? And I still got to think about which one's negative. -3 and +2 will add together to give me -1. They'll multiply together to give me -6. So I factored it. So be careful, because those numbers that you found to factor aren't the solutions, right? The -3 and the 2 go here and here, allowing me to factor. But remember the next step when solving. We're not done yet. We use the zero product principle. Set each factor to 0 and solve. So I get an answer of -2 and I get an answer of +3. So let me just take 1 minute and talk about that. The two numbers that allow me to factor this, two numbers that multiply together to give me -6 and add together to give me -1, were +2 and -3. Okay? But then I had to go a step further and set each to 0. So you notice my answer isn't +2 and -3, right? It's in fact the opposite of that. It's a -2 and a +3. Don't try and memorize how that all happens. Just do the work. Factor. Once you factor, set each factor to 0, right? And once you do that, there'll be a little more work to get your solutions. By the way, we can always do the check. I don't want to make this video too long. Both of those answers should work. I'm telling you that both of these are a solution. I'm just going to check one. My original equation was x squared minus x minus 6 equals 0. So when I plug in 3, I better get 0 as a result. So let's see what happens. 3 squared minus 3 minus 6. What does that equal? I'll draw a question mark. Does that equal 0? It better. 9 minus 3 minus 6 is 6 minus 6, which equals 0. Check. So I know that one's right. Okay, I'll let you check the -2. That one should also work out. Okay, moving along. Number 5. Remember the first step, set to 0. This one is eventually going to give you some problems that aren't set to 0. We'll have to do that on our own. But this one is already set to 0, so that's good. Now factor. First step in factoring, GCF. This one has one. The last one did not. Factor out the 4x, I get x minus 4. Factoring's done. Set each factor to 0 and go from there. Add 4 to both sides, gives me a solution, x equals 4. In this case, divide both sides by 4, give me a solution, x equals 0. Okay, last one for this video. 4x squared minus 25 equals 0. It's already set to 0. There's no GCF. I'm still checking for the GCF, but 4x squared, 25 have nothing in common. So what are my other methods of factoring? That's difference of squares. That's one we need to recognize. 4x squared has a square root, 2x. 25 has a square root, 5. So I've factored the problem, and now I apply my zero product principle, set each factor to 0, and solve. In this case, 2x equals 5, giving me a solution of 5 halves. And of course, -5 halves. Okay, hope that helps. Next video, we'll do ones that are a little more complicated.